Difference research. To powering PISA performance, we should count and recount before we add. My name is Alan Tupp. I am a curriculum architect at themathacademy.net. The Academy teaches teachers to teach mathematics as Menomath, i.e., as tales of many. The Academy is a Heidegger-inspired virus academy. It says, to learn, ask the subject, not the instructor. The full 31-page article may be found with this link. Let us look at the poor PISA performance in Scandinavia. We see that all numbers go down, Sweden especially, despite increased research funding to a national center for education. This made OECD write a report, Improving Schools in Sweden. The question now is, can difference research find a difference that will make a difference? Here is a list of different differences that we may find on the background of poor PISA performance, witnessing 50 years of low-performing math education research. 10. Different education. Classroom, half-year self-chosen blocks, versus multi-year forced lines. 20. Different mathematics. Bottom-up menu-based math from below, versus top-down set-based math from above. 30. Different research. Ancient sophism, Renaissance natural science, postmodern existentialism. 40. A different math education, showing the beauty of the simplicity of math. To master many, count and recount before you add. And when you add next to and on top, and forwards and backwards. How to power PISA performance, in a nutshell. The Greek sophists said, beware of choice masked as nature. A number language sentence is a tale of many. For example, the total is 5, t equals 5. Or, t equals 1 bundle 3 twos, equals 2 bundle 1 twos, equals 3 bundles less 1 twos, or 1 bundle 2 threes, etc. The predicate can be different, so it is a choice with alternatives. The subject cannot be different, so it is nature without alternatives. With one goal and many means, we may experience a goal displacement, if a means becomes the goal instead. By finding hidden differences, difference research can unmask means that are masked as goals. So, always use full sentences. If not, predicates become subjects, making a chosen means a goal instead. Education, and mathematics, and research. Education is a social institution. In sociology, Bauman warns against the danger of a so-called goal displacement, where the survival of the organization, however useless it may have become in the light of its original end, becomes the purpose in its own right. Mathematics and research produce truth claims. But, are the truths just choices masked as truths, creating a truth regime we all have to serve? In philosophy, Sartre says, in existentialism, existence precedes essence. In philosophy, Heidegger warns against true sentences with a subject and a verb and a predicate. Trust the subject, but doubt the predicate, it could be different. In counter-philosophy, the Greek sophists said, beware of choice masked as nature. Difference research asks one question only, find a difference that makes a difference, to unmask claimed goals, claimed existence, claimed subjects, and claimed nature, that instead turns out to be masked means, masked essence, masked predicates, and masked choices. Here are the main findings of difference research. Math as tales of many shows the simplicity of math. Meeting many we ask, how many in total? To answer, we math. Oops, sorry, math is not an action word, but a predicate. Take 2. To answer, we count and add. And report with tales of many, number language sentences, t equals 2 3s equals 2 times 3. There are 3 ways to count, bundle count, and recount, and double count. Bundle count gives units. Recount changes units. Double count bridges units by per numbers as $2 per 3 kilograms. Recount to and from tens. Here, multiplication and equations come before addition. To tens, t equals 5 sevens equals how many tens, equals 5 times 7, equals 35, equals 3.5 tens. From tens, t equals how many sevens, equals u times 7, equals 42, equals 42 over 7, times 7, equals 6 sevens. This is called a recount formula. Counting gives changing or constant unit or per numbers, to be added in 4 ways. Addition and multiplication unites changing and constant unit numbers. Integration and power unites changing and constant per numbers. Adding next to and on top roots early childhood calculus and proportionality. Early childhood calculus, t equals 2 threes plus 4 fives, equals how many eights? Early childhood proportionality, t equals 2 threes plus 4 fives, equals how many fives? Difference research, main recommendations. Visible and tangible bundles in tales of many. To improve PISA performance, the outsider, child, migrant, must touch and see and write the bundle and use full number language sentences in tales of many. Bundles equals units. And must count, and recount, before adding. Several counting sequences. T equals 7 equals bundle less 3, equals 1/2 bundle and 2. Here the total is the goal, the subject. Recount in the same unit, threes, to create, or remove, an over or underload. T equals 7 equals 2 bundle 1, or T equals 1 bundle 4, or T equals 3 bundle less 2. Seeing T equals 47, equals 4 bundle 7, equals 3 bundle 17, equals 5 bundle less 3, makes a difference in multiplication tables. T equals 2 times 7, equals 2 times, 1/2 bundle and 2, equals bundle and 4, equals 14, or T equals 2 times 7, equals 2 times, bundle less 3, equals 20 to 6, equals 14. A calculator predicts using the recount formula, where the operations, division, multiplication, subtraction, are icons for bundling and stacking, and for removing stacks to find the unbundled. T equals 7, equals 7 over 3, times 3, equals 2 bundle 1, threes. Difference research, main warning. The 3 times 3 goal displacements in math education. We first look at primary school. Numbers. They could be icons and predicates in tales of many. T equals 2 threes equals 2 times 3, they could show bundles. T equals 47 equals 4 bundle 7 equals 3 bundle 17 equals 5 bundle less 3, and T equals 456 equals 4 times bundle bundle plus 5 times bundle plus 6 times 1. Instead, they are changed from predicates to subjects, by silencing the real subject, the total. And place values hide the bundle structure. Operations. They could be icons for the counting process, as predicted by the recount formula that says, total equals, total over bundle, times bundle, or, from T over B times, B can be pushed away. Instead, they hide their icon nature, and their role in counting, and they are presented in the opposite order, addition, subtraction, multiplication, division, instead of the natural order, division, multiplication, subtraction, addition. Addition. It could wait to after counting and recounting and double counting have produced unit and pair numbers, and wait to after multiplication. Instead, it drops counting and neglects next to addition, and it silences bundling, and uses carry instead of overloads, and it assumes numbers are 10 based. Now we look at middle school. Fractions. They could be pair numbers coming from double counting in the same unit, and they could be added by areas, as integration. Instead, they are defined as rational numbers that can be added without units. This is called mathematism, true inside, but seldom outside classrooms. Equations. They could be introduced in primary school as recounting from 10 bundles to icon bundles, and as reversed on top and next to addition. Instead, they are defined as equivalence relations in a set of number names, to be neutralized by inverse elements, using abstract algebra. Proportionality. It could be introduced in primary school as recounting in another unit when adding on top, or by double counting producing pair numbers. Instead, it is defined as linear functions, or as multiplicative thinking supporting the problematic claim that fractions and ratios are rational numbers. High school. Trigonometry. It could be introduced in primary school as mutual recounting of the sides in a right-angled triangle, seen as a block halved by its diagonal. Instead, it is postponed till after geometry and coordinate geometry, thus splitting up geometry and algebra. Functions. They could be introduced in primary school as formulas, that is, as the number language sentences, t equals 2 times 3, with a subject and a verb and a predicate. Instead, they are introduced as set relations, where first component identity implies second component identity. Calculus. It could be introduced in primary school as next to addition, and in middle and high school as adding piecewise, and locally constant pair numbers. Instead, differential calculus precedes integral calculus, that is presented as antidifferentiation. 11. Different educational systems. Europe has line-organized, and office-directed education. From secondary school, continental Europe uses line-organized education with forced classes, and forced schedules. This forces teenagers to stay together in age groups, even if girls are 2 years ahead in mental development. The classroom belongs to the class. This forces teachers to change room. And, in lower secondary school, to teach several subjects outside their training. Tertiary education is also line-organized, preparing for offices in the public or private sector. This makes it difficult to change line in the case of unemployment, and it forces the youth to stay in education until close to 30. This makes reproduction fall to 1.5 child per family, making the European population dying out very quickly by decreasing it to 25% in 100 years. 12. Different educational systems. In the US, education is block organized and talent directed. Alternatively, North America uses block organized education, saying to teenagers, "Welcome, inside you carry a talent. Together we will uncover and develop your personal talent through daily lessons in self-chosen half-year blocks, academical or practical, together with one subject teachers. If successful, the school will say, 'Good job, you have a talent, you need some more.' If not, the school will say, 'Good try, you have courage to try out the unknown, now try something new.' The classroom belongs to the teacher, teaching one subject only. Likewise, college is block organized, easy to supplement with additional blocks, in the case of unemployment. At the age of 25, most students have an education, a job, and a family with 3 children, one for mother, one for father, and one for the state, to secure reproduction. 20. Different mathematics. We experience the beauty and the simplicity of mathematics when we look at the following parts. 21. The goal and means of mathematics education. 22. Totals as blocks. Digits as icons. Operations as bundle counting icons. 23. Recounting solves equations. 24. Multiplication tables simplified by recounting. 25. Double counting in different and same units creates pair numbers and fractions. 26. Once counted, totals can be added. But counting and double counting gives 4 number types, constant and changing unit numbers, and pair numbers, to add in 4 ways. 27. How different is the difference? Here we compare set-based and many-based mathematics. 21. Different mathematics. The goal and means of mathematics education. The set-based tradition. Mathematics exists as a collection of well-proven statements about well-defined concepts, all derived from the mother concept set. Mathematics is surprisingly useful to modern society. Consequently, mathematics must be taught and learnt, before it can be applied. The many-based difference. Many exists. To master many we develop a number language with tales of many, a manymath. Manymath defines its concepts from below, as abstractions from external examples. Metamath defines concepts from above as examples of internal abstractions. Manymath adds with units, mathematism adds without units, 3 plus 4 is 7, no matter the units. But, how do humans master many, before being educated? Let us ask a 3-year-old, how old next time? The answer is 4, showing 4 fingers. But, reacting strongly to 4 fingers, held together, 2 by 2. That is not 4, that is 2 twos. Observation 1, inside, children see what exists outside, bundles of twos, in space, and 2 of them, in time. So, children use bundle numbers with units. Observation 2, inside, children use full number language sentences, as in the word language, with a subject, a verb, and a predicate. That is 2 twos, shortened to t equals 2 twos. 22a, different mathematics. Digits as icons. Totals as blocks to be bundle counted. Icon numbers. A folding ruler shows, digits are, not symbols as the alphabet, but sloppy writings of icons having in them as many sticks as they represent. Thus, there are 4 sticks in the 4 icon, etc. Counting sequences. A total of a dozen sticks counted in 5s gives different counting sequences. 1, 2, 3, 4, bundle, 1 bundle 1, 2 bundles, 2 bundle 1, 2 bundle 2, or 0 1, 0 2, 0 3, 0 4, 10, 11, 22, or dot 1, dot 2, dot 3, dot 4, 1, 1.1, 2.2, or 1, 2, bundle less 2, bundle less 1, bundle, bundle and 1, bundle and 2, 2 bundle less 2, 2 bundle less 1, 2 bundles, 2 bundle and 1, 2 bundle and 2. Bundle counting. With a cup for the bundles, a total can be bundle counted in 3 ways. Normal, or with overload, or with underload, t equals 7, equals 2 bundle 1 threes, equals 1 bundle 4 threes, equals 3 bundle less 2 threes. Or, counting in tens with inside bundles, and outside singles. T equals 37, equals 3 bundle 7 tens, equals 2 bundle 17 tens, equals 4 bundle less 3 tens. 22b, different mathematics. Operations as bundle counting icons. We count by bundling and stacking, t equals 7 ones, equals 2 threes, and 1 unbundled single, equals 2 bundle 1 threes equals 2.1 threes. Thus, to count 7 in threes, we push away 3 many times, iconized by an uphill stroke, showing the broom pushing away the threes. With 7 over 3 equals 2. Sum, the calculator predicts that 3 can be pushed away 2 times. To stack the 2 threes, we use a multiplication cross, iconizing a lift, 2 cross 3, or 2 times 3, transforming the bundles into a stack. To look for unbundled singles, the stack of 2 trees we pull away, iconized by a rope, 7 pull away 2 threes leaves 1. The prediction t equals 7, equals 2 threes and 1, equals 2 bundle 1 threes provides the recount formula. T equals t over b, times b, saying, from t over b times, b can be pushed away. As for example 8 equals, 8 over 2, times 2, equals 4 times 2, equals 4 twos. To also bundle bundles, power is iconized as a cap, for example, 5 power 2, indicating the number of times bundles themselves have been bundled. Finally, addition is a cross showing that blocks can be juxtaposed next to or on top of each other. Counting thus provides the number formula called a polynomial. T equals 456, equals 4 times bundle bundle, plus 5 times bundle, plus 6 times 1, equals 4 times b squared, plus 5 times b, plus 6 times 1. So, counting creates three operations, to divide, and to multiply, and to subtract. 23. Different mathematics. Recounting solves equations. Recounting in the same unit creates overloads and underloads. T equals 7 ones, equals 2 threes and 1, equals 2 bundle 1 threes, equals 1 bundle 4 threes, an overload, equals 3 bundle less 2 threes, an underload. Recounting in different units means changing units, called proportionality. T equals 4 fives, equals how many sixes? A calculator predicts with the recount formula, T equals, T over B, times B, that T equals 3 bundle 2 sixes. Recounting between icons and tens gives multiplication, and equations. Recounting from icons to tens. T equals 5 sevens, equals how many tens, equals 5 times 7, equals 35, equals 3.5 tens, predicted by multiplication. Recounting from tens to icons. T equals how many sevens, equals u times 7, equals 42, equals 42 over 7, times 7 equals 6 sevens. So, the solution is, u equals 42 over 7, equals 42 counted in sevens, equals 6. So, a multiplication equation is solved by recounting, that is, by moving to opposite side with opposite calculation sign. Science and STEM are full of multiplication formulas. 24. Different mathematics. Multiplication tables simplified by recounting. In geometry, multiplication means that, recounted in tens, a block increases its width and therefore decreases its height, to keep the total unchanged. Thus T equals 3 times 7 means T is 3 sevens, that may be recounted in tens as T equals 2.1 tens, equals 21. In algebra, the full 10 by 10 table can be reduced to a small 2 by 2 table containing doubling and tripling, using that 4 is doubling twice, that 5 is 1/2 bundle, that 6 is 5 and 1, or bundle less 4, that 7 is 5 and 2, or bundle less 3, etc. Beginning with doubling and halving, visualized by snap cubes. T equals 2 sixes, equals 2 times 6, equals 2 times, 1/2 bundle and 1, equals bundle and 2, equals 12, or T equals 2 sixes, equals 2 times 6, equals 2 times, bundle less 4, equals 20 less 8, equals 12. T equals 5 sevens, equals 5 times 7, equals 5 times, bundle less 3, equals 5 bundle less 15, equals 50 less 15, equals 35. T equals 8 sevens, equals 8 times 7, equals, bundle less 2, times, bundle less 3, equals bundle less 2 bundle, less 3 bundle, plus 6, equals 100 less 20 less 30 plus 6 equals, 56. 25. Different mathematics. Double counting in different units, creates pair numbers, also called proportionality. Apples are double counted in kilogram, and in dollar. With 4 kilograms equals $5, we have 4 kilograms per $5, equals 4 per 5, kilogram per dollar, that is, a pair number. Double counting in the same unit, creates fractions. $4 per $100, equals 4 per 100, equals 4%. Questions. 8 kilograms cost how many $? We recount 8 in the pair number 4. 8 kilograms equals, 8 over 4, times 4 kilograms, equals, 8 over 4, times $5, equals $10. Likewise, we see that $20 buys 16 kilograms. So, to shift units, simply recount in the pair number. 26a. Different mathematics. Once counted and recounted, totals can be added. Adding blocks on top, the units are changed to be the same. And change unit is called proportionality. 2 3s plus 4 5s equals 1 bundle 1 5s plus 4 5s equals 5 bundle 1 5s. Adding blocks next to means adding areas, called integral calculus. 2 3s plus 4 5s equals 3 bundle 2 8s. 26b, different mathematics. Adding pair numbers as areas, called integral calculus. We ask, 2 kilograms at $3 per kilogram, plus 4 kilograms at $5 per kilogram, totals what? Here, the unit numbers, 2 and 4, add directly. But, the pair numbers, 3 and 5, must first be multiplied, before adding. And multiplication creates areas. So, pair numbers add by areas, under the pair number graph. 26c, different mathematics. With 2 by 2 different number types, we add, in 4 different ways. And, we solve equations, by moving to opposite side, with opposite calculation sign. Counting produces changing or constant, unit numbers and pair numbers. Addition and multiplication unites changing and constant, unit numbers. Subtraction and division splits into changing and constant, unit numbers. Integration and power unites changing and constant pair numbers. Differentiation and the factor finding root, or the factor counting logarithm, splits into changing and constant pair numbers. 27. Different mathematics. How different is the difference? Same questions, but different answers, from the set-based tradition, and from the many-based difference. Digits, are they symbols, as letters? Or are they icons, with as many sticks as they represent? Numbers, are they line numbers? Never with units, but with place values. Or are they area numbers, unions of blocks of stacked singles, bundles, bundles of bundles, etc. Always with units. Number types, are there 4 types, natural, integers, rational, and real, all without units? Or are there 2 types, positive and negative decimal numbers, with units? Operations, are they mappings from a set product to the set? Or are they counting icons for pushing, lifting, pulling, and uniting? Order, is that addition, subtraction, multiplication, and division? Or is it the opposite? Fractions, are they rational numbers, that add, without units? Or are they pair numbers, not numbers, but operators, needing a number, to become a number, so added by integration? Equations, are they statements, about equivalent number names? Or are they recounting from tens to icons, by reversing operations? Functions, are they mappings between sets? Or are they number language sentences with a subject, a verb, and a predicate? Proportionality, is it a linear function? Or is it a name for double counting into different units? Calculus, should we teach differential before integral, as antidifferentiation? Or should we teach integration first, as adding locally constant per numbers? Goal and means, is that to master mathematics, by means of few concrete examples? Or is that to master many by means of 3 actions, count, recount, and add many? 31. Different research. The ancient Greece dissension between sophist and philosophists. Difference research began with the Greek controversy between 2 attitudes to knowledge, called sophy in Greek. To avoid hidden patronization, the sophists warned, know the difference between nature and choice, to unmask choice masked as nature. To their counterpart, the philosophers, choice was an illusion, since the physical was but examples of metaphysical forms, only visible to people educated at the Plato Academy. The Christian Church transformed the academies into monasteries, but kept the idea of a metaphysical patronization, by replacing the metaphysical forms, with a metaphysical Lord, using an unpredictable will, to choose how the world should behave. 32. Different research. The Renaissance created natural science. Background: Viking descendants in the UK know how to sail, how to steal Spanish silver, and how to follow the moon to go to India on open sea, to buy silk and pepper with silver. But, how does the moon move? The tradition said, between the stars. Newton said, no, the moon is falling as the apple. But, why do moons and apples fall? The tradition said, they follow a metaphysical, unpredictable, will. Newton said, no, they follow a physical, predictable, will, by following formulas. But, what is the effect of a will, or force? The tradition said, Aristotle says, that a force upholds order. Newton said, no, a force changes order. But, how to use formulas? The tradition said, by using Arabic algebra. Newton said, no, we must create a different algebra about change, called calculus. 33. Different research. The Enlightenment century, 17 to 1800. Newton's physical will inspired the Enlightenment century, Locke, with its two republics. The US First Republic showed skepticism towards philosophy. This created US pragmatism, symbolic interactionism, grounded theory, action learning, and action research. The French Fifth Republic created post-structuralism, inspired by existentialism, with Kierkegaard, Nietzsche, Heidegger, and Sartre saying, in existentialism, existence precedes essence. Thus reacting against counter-enlightenment, where Hegel's metaphysical spirit is the basis for Marxism, and for the European line organized office-directed Bildung education. 34. Different research. French post-structuralism is inspired by Heidegger's, in sentences, trust the subject, but doubt the predicate, since differences disappear, when institutionalizing words, truths, cures, and education. Derrida says, words can be different, deconstruction. Lyotard says, truth can be different, postmodern skepticism towards metanarratives. Foucault says, truth creates regimes, with curing institutions, a school is really a prespital, mixing power techniques from a prison, and a hospital. Bourdieu says, education can be different, and stop using symbolic violence, and mathematics especially, to create a new knowledge nobility. 35. Different research. Inspired by its skeptical roots, difference research questions traditional words, and truths, and institutions. Designs different microcurricula, and macrocurricula. Reports, if a difference, makes a difference. Examples. Microcurricula, mathecademy.net, with YouTube, Mr. Eltap videos. Macrocurriculum, the simplicity of mathematics designing a STEM-based core math curriculum for outsiders and migrants, with the link below. 36. Different research. Difference research, for whom? For teachers, observing problems in the classroom. For teacher researchers, splitting their time between academic work at a university, and intervention research in a classroom. For full-time researchers, cooperating with teachers, both using difference research, the teacher to observe problems, the researcher to identify differences, together working out a different microcurriculum, to be tested by the teacher, and reported by the researcher, conducting a pre-test post-test study. Difference research begins by observing learning problems, and wondering, if we could teach differently. For example, a child saying, that is not 4, but 2 twos, showing that children bring two-dimensional area numbers to school, where one-dimensional cardinal line numbers then are forced upon them. Conclusion. Difference research has found 3x3 goal displacements in math education. In primary school, where numbers, operations, and addition, can be different. In middle school, where fractions, equations, and proportionality, can be different. In high school, where trigonometry, functions, and calculus, can be different. So please remember, to master many, count, and recount, before you add. A full 31-page article may be found on this link. This talk has been in English, a dialect from the Viking area, on the Danish west coast. You may know that the words 11, and 12, and 20, come from the Vikings, saying 1 levant, 12 levant and 20t, where levant means left. Thank you for listening, tak du for listening. Farewell, farvel.